Okay, so that was page 646, question number 1. We're working at 9.2 with our quantitative data. I'd like to look at number 3 at the bottom, because this is now introducing a new distribution. So we have been using in 9.1 and up until now the normal distribution, and that was working just fine. But now we are working with the t distribution, and I want to just bring up those couple of pages in your course pack. So on page 213 is where we introduce this t-curve. And the reason we introduce this t-curve is because we're estimating, we're not using it just to predict one thing. So in proportions, we're just predicting the proportion, and that proportion of success is used to predict this, the standard deviation. But in means, we're predicting two things. To make a confidence interval, we have to have the sample mean, and we also have to have the sample standard deviation, and they're two different things. And so because of that, we have to have this t-curve that's slightly different and slightly kind of smaller and compressed than the normal curve. And actually, the student's t-curve was actually created by a person working at Guinness Beer. Did you guys know that? So yes, at Guinness Beer, they were testing out the beer in Ireland, and this statistician person that was doing all their beer quality testing discovered that they needed to use a curve that was slightly different than the normal curve because they had small batches of beer. So just a little tidbit for the day. So it's going to look very similar. The biggest difference is that in our Statcrunch, we're going to use the degrees of freedom, and the degrees of freedom is n-1. And so on page 214, we have the instructions for Statcrunch. So we're going to go to Statcrunch, calculators, and T. So we'll go down just past the normal, and we're going to go to T. And then the only things that we enter for a T curve, a critical value for T, is the degrees of freedom and your confidence level. And you're always going to use the between, because we want the plus or minus symmetrical values. Okay, so that's on page 214. Okay, so that being said, let's just practice getting some of these. Now it's gonna come out of our confidence interval just like it did before in 9.1, but I think it's good to understand how this works. So let's go to my stat lab and get onto Statcrunch so we're ready to go. And it should be in, let's see. Okay. Okay, here we are. So we're going to go to stat and down to calculators, and we're going to go down to T, which is 2 below the normal. And we're choosing between, and you can see that all these A, B, and C, they're all using the same N, which means our degrees of freedom is going to be equal to 24, right? 25 plus or minus 1, so 24. And the first one, we want 80% as our confidence level, and we get our T values at plus or minus 1.3178. 1.318 is fine. And then on B, we have the same degrees of freedom, but this time our confidence level is 90. So we're keeping the sample size the same, but we're going to have a bigger confidence. So we would expect our red area to be bigger, and it is plus or minus 1.711. And then the third one again is the same sample size, but now our confidence is 99.5%. And it's even wider yet. So plus or minus 3.091. Oh, I thought, am I not sharing my screen? Oh, well, the whole time I thought I was. What the heck? Sorry about that. So how about we go back and do that again, since I thought I was. So stat and calculators, thank you for catching that. Our T, and we have to click on between. And then we're entering our degrees of freedom as 24. And the first one was 0.8. So sorry. It said I was sharing, but I must have just been sharing my paper still.
So you did, you go to calculator and then T and it brings this up and then you hit between.
Mm-hmm. Can you see my
But if
screen
you
now?
don't know your degrees yet, like the 24.
It goes by it's our sample size minus 1.
Oh yeah, you're right. Okay, thanks.
You're welcome. No worries. Everybody can see my screen, right?
Yes.
Okay. And then if we change that to 0.9, we get this. And then if we change that to 0.995, we get that. And like I said, there is going to be the same box in our confidence interval that lets us check to show the critical value, but I want to make sure you know where to find those, because we learned how to find the regular Z critical values when we did chapter 7, right? We did the normal curve and we did all the less than, greater than, and the between. But this is a new thing. It's similar in the way it looks, but it's set up a little bit different in what our inputs are. Is everybody okay to go to the next page? So on the next page, I just wanted to look at question number 4. And this was basically so we would get some practice on how to enter this into Statcrunch. So I'm just looking at this one here, number 4. And in Statcrunch, I think on that page, or I mean in your course back on like page 216, I think is where it tells us how to put this in. But we're going to go to Stat. And then we're going to go to, I'm going to show you at the same time. So we're going to go to Stat and then down to T stats. So just like in 9.1, we went down to proportion stats, we're going to go to T stats. And then we're going to click on one sample for now. Oops, T stats, one sample. And what we have in this table, we have all the summary statistics. So we're going to go down to with summary. Is everybody there? So we're going to enter in our X. Our sample mean is 98.6. Make sure everybody gets those in. 6, 1, 2, 3, and 12. And then we're going to choose confidence interval. So in chapter 10, we'll leave it at hypothesis test, but for now we're doing confidence. And then the other thing is make sure you click on show critical value. We don't need it for this table, but we're going to need that for when we fill out the formula. Everybody get that? So there is, let's just fill out the column, the first column that says confidence interval.
Yeah, okay. We're doing Zoom, so you're fine.
What'd you ask for, hon?
Oh, nothing. You're okay.
Oh, I didn't know if you had a question.
No,
So
you're good.
lower limit is 94.6416, and the upper limit is 102.5584. we'll fill in the margin of error column together in a moment. So let's just get practice entering these. And so let's go to the next one. We're gonna go back to stat and T-stats. And one sample with summary, and we probably could have just said edit and changed everything, but so this one's 75, 5.2, and 32. And this, did I change the last confidence to 92?
I don't think so.
I don't think so. This one, let's just do this one. This one's at 95. So this one's good. I think the last one I was off a little. Anybody change yours and didn't yell at me? This one is correct. This is a 95. I think I did not change the last one. So this one is the 73.1252. And our upper is 76.8748. Go back and add it. 98.6. 6.23 and 12, wasn't it? And this was supposed to be 92. I don't think I changed that on the first one. Yeah, it was off a little bit. The first one should have been 95 point, you can just do 2 decimals on that one to save some space from the error. 95.13 and 102.07. Sorry about that. I was like, wait, I did not change the sea level. The third one is slightly different. Very large mean and huge sample size. 48,400. Remember, do not put in the comma. And confidence interval, and this time, this was the 99.5. And there's our lower limit. It's 1198.4305. And the upper is 1201.569. I'm going to show my paper so you can see. Is everybody okay with? So I corrected my boo-boo there. Does anybody need me to go over how to get the confidence interval again? Those are good. So let's go to the margin of error column. So the margin of error, we looked at a couple different ways to calculate this. And you don't have to use my method, but I like to use the upper bound minus the point estimate. For us is the mean, but there's a couple ways you could do the upper minus the lower divided by 2. That's the width divided by 2. Or you could do the point estimate 98.6 and subtract the lower. So there's 3 different ways. For me, I'm going to do 1.0207 minus 98.6. And did everybody get 3.47? Thereabouts. If you use the correct decimals, then you'd be a little bit off from me. Okay. And the next one, again, I'm going to use the upper minus the midpoint. I'm sorry, the upper minus the point estimate. It's kind of the midpoint. And that one, I got 1.8748. And did everybody get for the third 1.5695?
Yes.
Okay. Okay, next. Switch to worksheet number 2. I just picked out random problems. Not random, I picked out intentional problems, but they were kind of scattered. The ones I thought were really good to look at. Okay. The next one I want to look at is here on problem number 2 on this page. And this problem has, it says a simple random sample that is less than 5% of the population size has been obtained for each of the following. So we know that the independence is met, right, for the central limit theorem. 3 questions, criteria, and the first criteria is a simple random sample. So we have both of those met. So the third is a question of normality. And we don't know exactly the sample size, but it must have been small because they gave us a normal probability plot. So does anybody remember how we use the normal probability plot? This was from chapter 7.3, the normal probability plot. Does anybody remember how we use that to give us some information about our normal requirement for the CLT that we did in chapter 8?
Wasn't it like if it was like not like the bottom one, it was like just like linear, more linear and spread it out and like normal? Was that what it was?
Yeah, so we want our normal probability plot to look more normal. So more linear, I should say, yes, which is normal. It indicates that our data is normally distributed. So this does look fairly linear on the first one. The second one does not. It kind of goes up and then it's close to the line and then up again. And then we've got this outlier here, which you can see from the normal plot and from the box plot. Excuse me. I've got a cold, probably good that I'm not at school today anyway. I started coming down with this on Monday.
Us too.
You too?
Mm-hmm.
Yeah, it's just like my head, it's like so much pressure in my brain. I'm like, okay, I know it's big, but it's like really. Okay, I got a chuckle out of Andrew on that. He's the only one I can see. Okay, so the first one, I would say, yes, we can use that T interval because the normal plot looks linear. Normal plot looks linear. And the box plot is symmetric, fairly symmetric, right? You can see that the limbs out here are good on the box plot. And it's the midpoint is fairly in the center of the median. So, and the box plot is symmetric. Now, the second one, we said the normal plot does not look linear, and you can see that it's definitely skewed and it has this outlier. So this one's a no. Normal plot is not linear. And there is an outlier. Okay, everybody good on that one? It's hard to see if your hands are raised, the people that are down here. I don't see, but it will tell me, I think. Okay. And I'm recording this, so I'll put it on the website if we need it on JetNet. Okay. So on the next problem, I wanted to give us an opportunity to practice getting the confidence interval, but also with some real data. But I was very nice and typed the data in already. So both examples we're going to do today that have data, I already typed it in. So you can go to Statcrunch. I'm going to share that with you so you can find it. And so let me get up here. So Statcrunch, if you go to My Groups and to file 21, I think it's on page 4. Page 4 at the top. Oh, nope, it got moved. Down at the bottom on page 4. 9.2 worksheet 3, problem 3. Nope, we added that one today. So it's page 3. There it is at the top of page 3. It says worksheet 9.2, number 2, problem number 4, dog ages. And it should look like this. Everybody in agreement with me on that? So they are, oh, something weird popped up. They're asking us for on our paper here, compute the following, give 3 decimal places, the sample mean, the sample standard deviation, and the sample size. Now, some of that comes out of the confidence interval, but not all of it. So I think it's appropriate while we're here in Statcrunch, let's just remember that we can find regular summary statistics in Statcrunch. So if we go to stat and summary stats and columns, so I'm going to keep right here, summary stats and columns, and then I'm going to choose my var1, and I'm going to click on N, and I'm going to hit my shift key, and I'm just going to click on all 4 of the ones down to standard deviation. I need the N, the mean, and the standard deviation anyway. So compute. And then there we go. So that's what we need for that. Number 4 anyway. So our sample size is 16. Our sample mean is 5.125. And our sample standard deviation is 2.604. And I'm going to show my paper so you can see all that. There you go. Like I said, the confidence interval is going to come out with the sample mean, but that's the only thing it gives. So B says, presume all the requirements are met. So our CLT requirements have been met. Construct a 90% confidence interval from these data. Show the formula, substitution, and results. So this is what I'm expecting for full credit on the worksheets in the final. So the formula, if we go to our yellow sheet, it's on page 273. Page 273, where we found it the other day. And we're looking at the one at the bottom there. And so the one I circled because it's got all the individual pieces. And then down in the middle, it says technology. It says where to go to in Statcrunch, which we've already done, but it's there for you if you need it. And then when we do have to prove the CLT requirements, they're listed here as well in the box. So the formula we're going to use is X bar plus or minus the T critical T. And that T alpha 2 is a whole number itself. That's why I circled it. And then we need the sample standard deviation divided by the square root of n. And we know a lot of these pieces. So we know 5.125. We're going to get the critical T from our confidence interval. Okay. So let's go ahead and I'm going to share my screen so that we can go to Statcrunch here. So we're gonna go to stat and down to T-stats because we're dealing with quantitative data. So one sample with data this time. So we have to tell it it's in the column of R1. We're gonna leave our optional things. We're gonna go down to confidence interval. And this is a 90%, I believe. So we have to change that to 90. And then I'm going to click on show critical value. Those are the only things that we have to worry about. Choosing our variable, changing it to the confidence interval, the correct level, C level, and then show critical value. And there it is. So our critical value for our formula is 1.753. And then our lower limit is 3.984, comma 6.266. Any questions on that so far? I'll let you guys work on a interpretation, and part D, I'm gonna go grab some water. Dying of thirst over here. Anybody want to share their write-up? Okay, I will. So we are, always start out with we are 90% confident that the true age of the canine clients. So we have a unit to talk about, right? And this happens to be age of the canine clients is between 3.98 and 6.27 years old. So just like I mentioned on Monday, if you round it just for the conversation piece of the interpretation, that's fine. But make sure you're giving the full decimals on the up here on the confidence interval. Everybody good with that? Andrew gets to talk for the whole class, unless anybody chimes in. So D says the dog groomer says that on average, their clients are less than 6 years old. Does the interval support or contradict the claim? Let's see if any of you can chime in on this one.
Would it support it because it's between the confidence intervals?
But it says
No,
that
it wouldn't.
they are
It's-
less than,
Yeah, it
and
says
since
less
it
than.
goes over 6, and it contradicts.
Okay, so yep, so on Monday we said if, I wrote this special today for the morning class. Let me see what I wrote. I thought it was really good.
What does say less?
So we're gonna say contradict. I'm gonna tell you how I had them look at it this morning. We're gonna say contradict because part of the interval is bigger than 6. So contradict means, does it go against or disagree with? And support means, does it agree with or support? So how I had them think about it this morning was this. I said all of the interval, so all of the interval must agree with the claim to support. So that's one way you can think about it. If the entire interval doesn't agree with the claim, then you have to say contradict. And because our interval is not completely less than 6, we have to contradict it. Any questions on that one? So, what's I gonna say? So on Monday, what I was telling the class is because chapter 9, 10, and 11 are a little bit heavier, and I already, if you look at your schedule, I allowed an extra week at the end of the semester. So what I'm planning to do is, I have one other big problem I wanted us to do today, and it's probably me. I didn't mean to move so fast, but I had one other big problem today, and then I was going to stretch it out. So Monday we would do the 9.4 section because these are definitely heavier sections. So Monday we'll do some problems for the sample size stuff. And then I already moved the dates. You can see in Statcrunch that I moved the dates for your chapter 9 review worksheet can be turned in next Wednesday. And then your project will be turned in the Monday before Thanksgiving, your chapter 9 project.
Okay.
So, and you'll see I moved all the chapter 10 and 11 things to accordingly. So
When is
go ahead.
when is our chapter 8 project gonna be due then?
Oh, and I sent that out yesterday, didn't I? Andrew, I'm glad you caught that. I meant to do that with us in class, and we have time today, actually. I'll go to Statcrunch because I want to show you, I want to go through the project with you anyway. So let's just take a minute. And let me pull up Statcrunch. I'm giving everybody credit for the chapter 8 project because I wanted to spend time doing that in class together. I thought it was a good one to do together. So the chapter 8 project. Go away. Okay. So the chapter 8 project asked us to go into the applets, and it wanted us to go into, I think it was the sampling distributions. And they wanted us to basically see that a single class could maybe have like one student that scored really high on an exam or one student that scored really low, right? But from class to class to class, our average of the classes should be pretty much the same. And so we wanted to talk, that's what we were trying to show in the chapter 8 project. So if we go in here and I say, I want to do a bell-shaped curve, and let's say our population, we're drawing samples from a bell-shaped curve that has a mean of 25 and a standard deviation of 5. Okay. And then once I'm in here, this is going to let me draw a bunch of samples. And I want to do samples of size 5 at first. And I'm going to do this 1,000 times. And you can see that my one sample that I got of size 5 had a mean that was lower than our population mean, and a little bit skewed left a little bit. And its standard deviation was a little bit higher than our population standard deviation. But the 1,000 samples got pretty close, right? They were pretty close to the population. And the 1,000 samples, the standard deviation was much smaller than the population standard deviation. Now, let's say I did a sample size of 30, and I'm going to run this 1,000 times again. So my one sample of size 30 had a mean higher than the average this time. It wasn't as much skewed left. And the standard deviation was just a little bit under the population. But look at what happened to our 1,000 samples. Our mean and our median are both extremely close to 25. It's very symmetric, and look at how small the standard deviation is. So the bigger the sample size, let's say I did a sample size of 100 and I did this 1,000 times. You can see it's again getting very extremely close to 25 for the one that has 1,000 samples, and the standard deviation just keeps getting smaller and smaller. Because when you have big samples like that and a lot of them, they're not going to vary from each other that much at all. So they're going to get extremely small in the standard deviation. Then if we went and said, well, let's say we started with a population that wasn't symmetric already, it was actually right skewed. Okay, so here's our population is actually right skewed, and you can see that because of the mean and the median. And now I'm going to take my sample size of 5 again, and I'm going to run this 1,000 times. And my one sample here of size 5, it was very skewed, right? Our standard deviation was quite high. The 1,000 samples down here at the bottom got much closer to the 14, and the standard deviation's much smaller as well. And look at it's actually looking pretty normal, isn't it? So let's say I took my sample size of 30 and I ran that 1,000 times. And again, you can see that the one of the 1,000 samples is looking very normal. So even though you might have a sample that comes from a population that's originally skewed, the sampling distribution, which is what I'm circling down here in the green, the sampling distribution is how the samples are comparing to each other. And so how they're comparing to each other means that their deviation is very, very small. They're very similar to each other, and they all have about a mean of 14. And that's because they're not going to vary from each other much at all. So that's essentially what the Chapter 8 project was getting at, is that when you take samples that are larger and you take a lot of samples, it doesn't matter if you start with a normal population or a skewed population, the sampling distribution itself down here in green will always become normal with a very small standard deviation. So voila, there's your Chapter 8 project. You're welcome. Okay, so before we do the last big problem, I did want to go on to JetNet and kind of go through the project, if everybody's good with that. I wanted to explain the Chapter 9 project. The Chapter 9, 10, and 11 projects all go together. They're all surrounded by this data, this candy data that I mentioned, I think last week or Monday in class. So if you go down to Chapter 9 project, which is not due for a couple weeks, where are we? And then this week, time's flying when you're having fun. So if you go to week 13, that's where the project is listed, but you'll want to go there and find a link. She used to put papers of it in our course pack, but I'm not sure there's papers of the project in the course pack anymore at all behind your Chapter 9 worksheets. So you might want to just print this out. So here's a link for the project. I'm going to open that up so you can see. And like I said, you may want to print this out so you can write on paper. So it says you must also obtain your own data sources. Now, if you do not want to buy candies or can't afford it, it doesn't matter. Just email me separately. Don't send me a remind text. Email me and let me know, and I'll send you data because I like everybody to have different data. If you decide to buy your own because you like Skittles and M&Ms, which I do, then make sure you're buying the share bag or bigger, the one that's, it used to be called the normal bag, but now it says sharing size. I don't know why. But maybe there's one a little smaller than that. As long as it's not the itty bitty ones that you would give out at Halloween. So if any of you have Halloween candy left over, shame on you that you still have candy left over. And if you do have the little bags, you can't use those snack size ones. We need sample sizes bigger. They'll only have like 4 to 8 candies in there. So use the little bit bigger one. And here are your choices. So for the M&Ms, you can use plain peanut, which are the best, peanut butter
Amen.
or almond. Thank you, Ashley. Peanut butter, gross. I love peanut butter, but not with M&Ms. Peanut M&M is the best. So circle which one you're using, and then you're going to sort out your candies and you're going to label them here. You're going to let me know how many of each color and then the total. And then your Skittles, I would like you to buy a regular Skittles. Now, I agree that all the different flavors are amazing. Like the Hawaiian purple bag is really good. I love this. The sour Skittles are amazing, but I want you to only buy the regular because then you'll have the regular colors. Okay. And then give me the colors of each and then your total. Then you are going to let me know which kind you purchased for the M&Ms. And so chapter 9 is going to be all about the M&Ms, but the data that you reference on the prior page is what I'm assuming you're using for all of 9, 10, and 11. Okay. Is everybody with me? Chapter 9 is going to be the project about the M&Ms. Chapter 10 is going to be a hypothesis test about your Skittles. And chapter 11 is going to be a comparison between the two samples, the two candies. Okay. Okay. So you're going to answer which color had the highest count, which color had the lowest, and you're going to choose one of those. You're going to tell me the color that you chose between your two up here. You're going to give me the count is your X, your sample size that came in your candy bag is your N, and then you're going to find that P hat. So this is all back like chapter 9.1, remember? Qualitative data. Then you're going to show me your 3 central limit theorem requirements here. I need them spelled out. Don't just write them. Give me the numbers, verify everything. Then question 6 has you calculate the confidence interval just like we did on your paper. I want you to fill in these values and then give me the output from Statcrunch. Don't put the whole big thing in your calculator. Then question 7, sorry, is asking a question about if you had a bigger bag of candy with a higher sample size, what would happen? Then question 8 says, find your square. So if I picked peanut, which I would, and I like the color green, then I would highlight this 15% because the company says that 15% of the candies in the peanut M&Ms would be green. And then down here in the box, I want you to tell me, right here it says, you claim that the proportion of candies of your chosen color is different than what you highlighted. So you're going to use your confidence interval to tell me if 15% falls in your confidence interval or not. So that contradict and support thing. Any questions? So essentially what we've just done actually on Monday, because Monday was all about proportions. Everybody's good so far? So the last problem that I would like you to work on, you can work on it, not work on it, stay, not stay, for today, is question number 3 on page 652. It's a great problem that kind of, the data set is in Statcrunch, by the way. So go back. Oopsie daisy. Let me go back to Statcrunch. So if we go to my data, it's on the last page at the bottom. We just added it this morning. There it is. So I would like, if anybody wants to take a break or whatnot, you can look at this at your leisure. But I would like you to go through A is proving the conditions are good. And then B is constructing your interval, C is interpretation, and then D is a question that we're trying to claim something's different. So I will be here and I'll wait a few minutes for you all to get started on it, and then I'll kind of fill in as we go too, so that we can all verify that we're on the same page. I'm gonna grab some water and I'll be back. Okay, so the problem on page 652, let's go ahead and verify the conditions. So they told us that they had a random sample. And for independence, we could go a couple different ways. We know the population this time is 19.6 million. So we could say that we have how many in our sample? 3, 6, 9, 12, 14. Is what I thought, yeah. From earlier. So we could say our sample of 24 is less than 5% of 19.6 million, and we don't even need to figure that out because that's an obvious 5% of 19.6 million is more than just a million. So 24 is definitely less than that. And then our last one is normality. And because our sample is equal to 24, but it's less than 30, that's why they gave us this normal plot. So the normal plot, if they give it to you, that's usually because our sample size is too small. Remember, I would never ask you to create one. And our normal plot looks pretty linear, I think. Let's see if anybody has any questions on those three so far. Everybody doing okay? Shelby, Cassie, Lainey?
Yeah, I had that.
Yeah, I'm good.
Okay. Okay, so let's do the confidence interval. We've got our X bar plus or minus our critical T value. And then our, I always want to do that. It's, the S is not under that, so it's the square root of n. I always want to write that incorrect. And so we need to go get some sampling information, right? Some summary statistics here. I'm going to do that. In Statcrunch. So my data up, I'm going to go to summary statistics and columns, and I'm going to choose my first bar variable, and I'm going to get everything through my standard deviation there. So that's everything I need for my filling out my formula. Let's make sure that's all good. And then we can go ahead while we're right here and go to stat and t-stats. One sample, this time with data again. There's our variable and our confidence interval. And this time we do want a 95, so that's good. And I do want them to show me their critical value and compute. And there it is. So our critical T is 2.068. And our lower limit is 9384.3674, 16147.716. Okay. So I'm gonna share my paper there so you can see how I have it all filled out. Anybody want to share their interpretation?
I can.
Awesome.
I said we are 95% confident that the true proportion
Mhm.
of Capital One credit card customers.
Is it true proportion?
I don't know.
What are we trying to find?
No, it's not proportionate. It'd be the, wouldn't it be like money, like the debt, I guess?
Yep, because they're looking at, now we have a unit and our unit is dollars because it's the amount of debt that people have on their credit card, these Capital One customers. So I agree with everything to here. We are 90% confident that the true, let's say, credit card debt for Capital One customers. Okay, now you can probably finish it.
Have credit card debt between 9,384.37.
Yep, so, and that's gonna be dollars, right? Make sure you have your units on there, everybody. So 0.37.
And 16,000.
$72?
Yep.
Awesome. Thank you. Excuse me. I'm glad that that came up because that's important when we're talking about quantitative data. We're going to not use proportion and we're going to talk about the, and really it's like the true average credit card debt, right? For Capital One customers. So true average credit card debt for Capital One customers. Okay. And last but not least, it says a journalist claims that on average, Capital One credit card customers carry less than 16,000 in credit card debt. Does our interval support or contradict that claim?
It contradicts
And why is that?
because our interval goes above 16,000.
Okay. Because our interval is above 16. Excellent. Excellent, excellent. So I'm happy if anybody wants to stay and work, like get started on their chapter 9 review worksheet. If you have questions still on your chapter 8 review worksheet, kind of up to you to use this time if you just want to work. MSL, whatnot.
Okay, I'll see you guys Monday.
Okay, bye.
Bye.
So I have a question.
Sure.
So it's on the chapter 9 review worksheet.
Let me grab it. So I have an educated answer. Oh, it's right here. Okay, what question?
It was on the first page. It was question 2. I'm confused.
I'm confused. Because it's asking for how many fish is she going to need to catch? So what her sample size is? And we haven't talked about that. So you'll be able to go back and answer that one. I would just circle it. You'll be able to go work on that after Monday. It's 9.4. If you want to work ahead in 9.4 from the notes that you already took, you can go, but go ahead and try answering them.
Okay. So will that be for, so when it says how many fish, so it'd be, is it kind of like the same thing as on 3 on the other side? Because
On number 3.
Yeah,
So number 3 is also asking for a sample size. Yep. So you can do number 1. You should be able to do 4 and 5 and all of 6 and all of 7.
okay. All right. I was just making sure like that I wasn't like did I like not like
Right.
was I not paying attention or like I just like
Nope. You were
Okay.
totally paying attention.
all right. Okay. Then I'll just do those and then once we talk about these, I'll do the rest of that. So
Yeah, after Monday, you should be able to finish out those last couple of problems.
okay. All right. Thank you.
You're welcome, dear.
Have a good day.
You too.